The oil pressure low, stop engine warning can appear even when your oil level is completely full. This critical alert indicates a serious problem within your engine's oil circulation system that requires immediate attention. It's crucial to understand that oil pressure and oil level are completely different measurements. Oil level refers to the quantity of oil in your oil pan, while oil pressure measures the force at which oil circulates through your engine. Normal oil pressure ranges from 10 to 20 psi at idle and 25 to 65 psi at highway speeds. The warning system triggers when pressure drops below the critical threshold of 5 to 7 psi. When oil level is adequate but pressure is low, the most common cause is a faulty oil pressure sensor, accounting for 40 to 50% of all cases. This sensor monitors pressure and sends signals to your engine control unit. A failing oil pump is another major cause. The pump's internal components can wear out or break, preventing proper oil circulation. This broken oil pump gear shows the type of mechanical failure that can occur. Worn engine bearings create excessive clearances that reduce oil pressure. These damaged bearing shells show the wear patterns that allow oil to escape instead of maintaining proper pressure throughout the engine. A clogged oil filter forces the bypass valve to activate, reducing overall system pressure. Additionally, using the wrong oil viscosity can significantly impact pressure readings throughout the engine. Modern vehicles use enhanced engine control units and highly sensitive pressure sensors that can detect variations as small as 1 to 2 psi. Some 2024 and 2025 models even incorporate AI-driven predictive maintenance systems to forecast potential oil pressure problems before they become critical. Diagnosing low oil pressure requires a systematic approach to identify the root cause accurately and avoid costly misdiagnosis. The first step involves basic verification. Check the oil level using the dipstick, examine oil condition for contamination, and listen carefully for knocking or unusual engine sounds that might indicate bearing wear. A crucial diagnostic step is verifying sensor accuracy using a mechanical oil pressure gauge. This involves comparing the mechanical gauge readings with the electronic sensor output to determine if the sensor is providing false readings. Modern diagnostic tools provide real-time monitoring and detailed analysis. Digital pressure gauges offer continuous readings, while OBD2 scanners can analyze sensor data and identify fault codes related to oil pressure systems. Repair costs vary significantly depending on the root cause. Sensor replacement is the most affordable solution at $150 to $300. Oil pump replacement ranges from $800 to $1,500, while engine rebuilds for worn bearings can cost $3,500 to $7,000. Prevention is key to avoiding oil pressure problems. Regular oil changes with correct viscosity, weekly oil level checks, and annual pressure testing for high-mileage vehicles can prevent most issues before they become critical. Emerging trends include condition-based maintenance systems and smart oil monitoring. These technologies use sensors and AI to predict problems before they occur, moving away from traditional time-based maintenance schedules to more precise, data-driven approaches.